this parabola. Now this parabola is the equation x minus 2 squared minus 10. And what we're going to do is, if you're a colored person, you can get a colored pencil, colored pen. We're going to make a couple graphs that some people like to see. Different colors. Because it looks prettier. Hopefully don't mess up. You don't mess up. Alright, so what we're going to do is we have two equations. On the first one, we're going to graph, this is the equation that's going to be our g of x here, the 2 times f of x. Now what that's called is we are going to, and we're going to look at it first, then we'll talk about what the numbers do. We are going to vertically, so vertically, do you think that's the x or the y? For vertical, vertical's up and down, so that would be the y's. We're going to vertically stretch this graph 2 times. So we're going to multiply all the y coordinates on this graph by 2. So we're making them longer. So for example, when I look at this point here on my graph, that ordered pair is at -1, 0. So I'm only, bless you, I'm only dealing with the y's here. The y value is 0, and I multiply 0 by 2. What happens to the point? It stays at 0. So this point actually stays in the same spot. Okay, that's not hard to do. The next one down here, I have a point at 0, -5. If I multiply this y value by 2, where does it go to? -10. So this point actually gets stretched down to -10. I'm going to erase that one right there. Okay. All right, if I look at the next point, I'm at -8. So I'm at 1, -8. If I multiply that y value by 2, where are you at? -16. So this point goes all the way down to -16. The next one at 2, -9 would be stretched to -18. All right, and now we're symmetric. We're going back up, so that's easy to plot the rest of the points. And when you connect them, you get a really long looking parabola. Oh, that's a good one. It did not look that good last period. I'm glad I made the video this period. Wow. That's a good parabola. It's the little things, guys. It's the little things. Oh, mine's really bad. That's okay. No one's looking at it. So we have our parabola. Does it look wider or skinnier? Well, it's kind of hard to tell on this one, but it's hard to see if we didn't see up the top, but it's going to actually be skinnier. When I pull it down, it makes the graph look a little bit skinnier. And you'll see on the next one, then it'll look wider. So now, if you're using color, you can pick a different color. And this time, we are going to vertically compress. That means squeeze it down, make it shorter, by 1/2. So this time, we're multiplying all those y coordinates again, this time by 1/2. So we're going to do the same thing. The 0, the y coordinate at 0, does it change when I multiply it by 1/2? No. So both of those zeros are going to stay at the same spot. If I go down to -5 this time, what's 1/2 times -5? -2.5. So this point comes up here to -2.5. I'm going to do the other side at the same time. All right. What if I get down to -8? Where does that go when I multiply by 1/2? -4. Okay. And -9 goes to -4.5. Now, when you connect those, once you make the picture, I'm erasing that. I spoke too soon. That one wasn't good. Let's see. That was a little better. Still not great, but it's. So does this graph, it looks shorter, but does it look wider or narrower? Like ultimately, it's going to go out wider, right? So when I vertically compress it, it makes my graph look a little bit wider. Now, what points did we not change here? The x-intercepts. So the x-intercepts did not change. Why did they not change? Think about the ordered pairs for a y-intercept. We had 5, 0, and -1, 0. What are their y values? 0. And if you multiply 0 by anything, what do you get? 0. So the x-intercepts didn't change because they have y values of 0, right? So when we vertically change a graph, the roots stay the same. Those ones are planted in the same spot when we pull the rest of the graph up or push the rest of the graph in. Okay. Not too hard so far? All right, now what I need you to do is I forgot to have you get this out, but you need to get out your transformations chart. So we're going to add to it. This is on the bottom of your notes as well, but we're going to add to our chart here. We have done 6 transformations so far. You had your quiz today. While you're getting it out, I'll chat with you. We did up, down, left, and right on your quiz today. And then yesterday, what we did was we reflected our graphs over the x-axis and over the y-axis. We're going to add 2 more rules on here, and then on Thursday, we'll add the last 2. All right. So the rule is, we have seen equations, and I'm going to write it on the side board over here, that would say y equals 2 times x plus 4 squared minus 1, right? We've done complete the square, we've done different ones where we get a number out in front. That number that ends up being out in front of our parentheses, that is what tells us whether I have a vertical stretch or a compression. So for example, if I see a 2 in front, like I have in this first box here, that is called a vertical stretch. And we're going to just say, I'm going to write here by C. Now there's a couple of different ways. If I had a 2, I could say I'm vertically stretching my graph by 2. You might also hear Mr. Graham or I, if you talk to Mr. Graham, say we're going to vertically stretch by a factor of 2. Either one of those is correct. You just have to be able to understand what we're saying here. Okay? But we're looking at the number in front. Now we're really only technically taking the absolute value of the number in front, because what if I had a negative there? Right. What does the negative we learned yesterday, what does that do to your graph? It reflects it over the x-axis. So that negative doesn't change. It's still vertically stretched. It's still longer. It's just upside down now. Okay? And then, if I were to change this to be 1/2 times x plus 4 squared, when that number in front of the parentheses is less than 1, so a fraction between 0 and 1, that's called a vertical compression. And we'll say that that's a vertical compression, again, by C, or you could say by a factor of C. So here we would have, you could say vertically compressed by 1/2, or we would say vertically compressed by a factor of 2. So you don't say by a factor of 1/2, it'd be by a factor of 2. But if you just say by the number, it'll always be right. Okay? So what I need you to do is go back to your notes, and we're going to flip to the back of the notes right now. Okay? The hardest part about vertically stretching compressing is not recognizing it in the equation, it's recognizing the vertical stretch and compression while you're looking at the picture of the graph. All right, looking at the equation, it's easy to say, oh, I know what the 2 or the 1/2 out in front does. In order to tell if you have a vertical stretch or compression, we need to make sure we understand the parent function. And we've spent a lot of time with the parent function, so I'm not going to beat this horse here, but we need to know the pattern, that if I have a vertex, and every time on my parent function, if I go out 1 in the x direction, that means I have to go up how many? 1. And then I go out 2 and I go up 4. When I see a difference in the vertical change, that's when I'm going to have a vertical stretch or compression. So all we're going to do for the next couple is just decide vertical stretch or compression and by how much. So when I look at this original graph, I started the vertex. I do have points plotted because it makes it a little easier for the first couple. But if I go out 1 box, how many do I go up this time? 3. So usually how many do I go up? I go out 1, up 1. This time I went up 3. And if I go out 2 boxes here, how many do I go up? 12. And usually I go out 2, up 4. So how much difference is this than the original parent function? I kind of hear whispers, but I can't tell. I normally go out 1, up 1, right? So this time I'm out 1, up 3. So are you bigger or smaller by 3? Bigger. You're vertically stretched by 3. So you would say that there is a vertical stretch And you can say by a factor of 3, or you can just say by. I'm just going to write by 3. And yes, you can abbreviate it. Usually I'll abbreviate vertical stretch VS, vertical compression VC, mostly because I get lazy when I write it all the time. Now, I know it's not written on there, but I'm going to have you write the equation of this graph as well. Now, my graph, they're all set, I don't want to say centered, but they're all located at the origin. So we didn't go left, right, up, or down. All we did was stretch the graph. Let's just make sure we understand what that vertical stretch does to the equation. Okay? The vertical stretch by 3 is just going to put a 3 right in front. And then since we didn't go left or right, we just have x squared. So 3x squared is the equation of that parabola. Now when I go to number 2 here, I start at the origin, I go out 1. How many do I go up? Half. And if I go out 2, I go up 2. So how much is that compared to the original parent function pattern? Got very quiet all of a sudden. Normally we go out, if you need to, the parent function's on your paper. Out 1, up 1. This time I went out 1 and I went up a half. So you're half as big. So is that a stretch or a compression? Compression. So this is a vertical compression by a half. So when I vertically compress, how do you think I write this equation? Y equals 1 half x squared. But again, I didn't go left, right, or anything, so it's just x squared.
Is it always 1 half?
For this, yes. So vertical. So we're going to do horizontal stretching compression in a couple days. For vertical, it's always what you expect it to be. So a compression is the fraction. A stretch is a number bigger than 1. When we get to horizontal, it's going to switch. But for now, it's what you expect it to be. So now this time, I don't have the points labeled. So if I go out 1 in this graph, how many do I go up here? Out 1, up 4. So what's the transformation? A stretch or a compression? A stretch. So I have a vertical stretch. And how much did I stretch by? By 4. Right? Normally I go up 1, and this time I'm going up 4. So what would your equation here be? Yes. We'll make it more challenging in a minute. Or at least we'll add more things on. Last one here. If I go out 1, can I tell by looking at this dot how much I went up? No. So if I go out 2, can I tell how much I went up?
No.
No. If I go out 3, can I?
Yeah.
So I go out 3, up 3. Usually when I go out 3, how many do I go up? 9. So what fraction is 3 of 9? It's 1/3. So this is a vertical compression by 1/3. Okay. So that equation would be y equals 1/3 x squared. Good so far? Now let's start to combine this vertical stretch and compression with everything else we've done in units so far. So we have 3 more graphs here. We're going to list the transformations by looking at the picture and then write the equation. So when you look at this picture, what do you notice about it first? It can be anything, but what do you notice about what's happened to it? It's stretched, okay. So, yeah, we can do higher or lower, that's fine too, but we'll do stretched first. It does look longer. If I have my origin, or not my vertex here, and I go out 1 dot from it, how many up do you go? 2. So would you say that's a stretch or compression? Stretch. So I'm going to abbreviate VS, just the same. Vertical stretch by 2, because I'm 2 higher. All right, so we took care of the vertical stretch. What else do you notice happened to this graph? It went up 4, right? It's up 4. And then it went right, how many? 3. Well, now that I know the transformations, I can write the equation. So y equals, when I write my equation, I always have to start right on the left. So I'm going to do the vertical stretch first. That goes in front. So you're going to write the 2. And then after that, it's exactly the same as what you were doing on your quiz today. How would you say, does right or left, right or up go on the inside? Right. So how would you say we want right? -3. And then up 4 would be +4. So that is the equation of that parabola. Right, now number 6. What do you notice about number 6 right away? It's upside down. What do I call that now that it's upside down? We reflected over the x. So this graph reflected over the x, that's why it's upside down. What else happened to it? It got wider, so that's a vertical compression. We have to figure out by how much. So if I go out 1, can I decide yet necessarily? No. I went out 2 down 2. And usually it's out 2 down 4. So it would be a half. So this had a vertical compression by 1/2. And then there's one other thing that happened after you flipped it. You went down 4. Yeah. So you have those 3. Which one do I have to start with when I write the equation? The reflection. And how do I say that it was reflected? A negative. Yep. And then a negative 1/2, because that's my vertical compression. Now, do I have to put parentheses if I didn't go left or right?
Yeah.
Nope. X squared, and then down 4 would be a -4. So there's your equation. Nope. Not at all. Yeah, that's fine. Put parentheses. You can do this. It's all good. All right. Last one here. What do you notice about it? It went what? I didn't hear you. It's wider. Okay, so let's decide what happened. I can't tell from 1, but if I go out 2, how many do I go up? 1. And usually I go up 4. So what fraction would that be? 1/4. So I vertically compressed by 1/4. 1/4 of the regular height. What else happened to my graph? Up 2. All right, and I think that's it. So our equation will be y equals, what do you think? 1/4 x squared plus 2. Now I do want to do one problem on the practice with you. So flip over. We're done with the notes, but there's one problem. We didn't actually make a graph together today. So the first one, but we're going to do this one. Number 6. So the bottom problem on the front of your practice. Now, what we're going to do next time we do notes, so Thursday, is what's called multi-step graphing. So when we graph, we're going to have all these transformations, and we're going to do them kind of step by step. I don't have multiple graphs here, so we're going to try to graph this new parabola that we have the equation for all in one step. So when I look at this equation, we need to first tell me what happened. What are the transformations to the graph? So when I find the transformations, I start on the left of it, and I start with a negative. What does that negative out in front tell me happened to the graph? Yep, so I reflect over the x-axis. Good. Okay, what about a 1/2? Is that a stretch or a compression? A compression. It's less than 1, so I have a vertical compression by 1/2, so my graph is half as tall. And what's the +4? Up 4. Okay, so we are going to graph that parabola with those 3 transformations on the grid. Now you can graph it one thing at a time. If you wanted to, you could graph the reflection, then you could compress it, make a new graph, and then move it up. But I'm going to try to see, let's do it all in one step if we can. If not, you can graph it multiple times, but it's not going to be that bad all in one. So I always start with the vertex. That's the easiest point to start with. If I'm at the origin here, and I reflect that point over the x-axis, does it go anywhere? No. Okay, so we're still here. If I vertically compress that vertex at 0, does it go anywhere? No. What about the up 4? Yes, so it moves up to here. So at least we know that's where our vertex is now. So we plot our vertex. Now I'm going to work to the right. If I can do all these points on the right, then because of symmetry, I can do the other side. So I start here at this first point 1, 1. I'm going to reflect it over the x-axis. So now I'm down below. If I vertically compress that by 1/2, where am I now? Vertically compressed. So if I'm at -1 times 1/2 would be -1/2. -2 would be a stretch. So now instead of at -1, I'm up here at -1/2. And then I take that point and go up 1, 2, 3, 4. Okay, so it's a little bit closer than usual. Are we okay with that? Yeah? No? Now if I go to 4 and I reflect over the axis, I come down to here. If I compress that by a half, where does the negative 4 go to? What's half times negative 4? Negative 2. So now this point is compressed up. It's half as tall. And then from there I move it up 4. So you're at 2, 2. If you don't like doing this all at once, then you don't have to. You can do it at different times. All right, now we're at 9. I flip that over. I don't have 9 on my graph, but that's okay. I have to take half of that for the compression. Where does that take me to? Negative 9 would be to negative 4.5, so there's this dot, and then I move it up 4. 1, 2, 3, 4. And there's your point. So now you have half your graph. You can follow symmetry and plot the other side. And you should see that your graph looks a little bit wider because it's compressed. It's flipped and it's moved up. Do you want to do a ton of graphing of these? Because again, we're going to do that multiple step graphing in a couple of days. But at least I got you started. So my suggestion for you today is at least try to do this.